You're watching the free version of SynthEyes Essentials. For projects and footage, head to BorisFX.com for the premium download. Hey, welcome back to the second part of this class. We already explored a lot of what SynthEyes is actually doing to create a proper coordinate system using the *3 method. Let's jump right back in and take a close look at how to deal with manual alignment. We did do this a couple of times before, so in the 3D room, with whole being activated, I'm using the translate and rotate controls to bring my scene into place. Let me switch to the quad perspective view so that you can see what is going on in regards to the ground plane. With a little bit of fiddling around, I'm able to get that into place pretty close to what we had with the *3 method. And drawing up that box is as easy as before. And now let's head over to the solver and refine our scene. I'm doing the exact same steps as I did with the *3 method. But this time, once I hit refine, there's a substantial jump. Our box almost quadruples in size, showing us that the scaling and positioning of our scene is severely altered. Why? Because nothing is holding SynthEyes back. It is literally unconstrained. When we go to the coordinates room, we see that there are no constraints in place. So we need to do this after the fact. With the *3 method, we defined constraints that then aligned the scene. This time, we're going to do it backwards. We already aligned the scene, but we need to give it the corresponding constraints. The first thing we need to do is to get the trackers we want to use as a constraint up into the constraints list. We can achieve this by turning them into seed points. What is a seed point, you may ask? The seed point is best described as a tracker that you already know the coordinates in 3D space for. That can be really helpful for some of the more advanced workflows inside of SynthEyes, but for us, this is a really easy way to turn this tracker into a constraint for our coordinate system. Once we turn it into a seed point, it shows up with values really close to 0, but we want to mimic what we did with the *3 method, and that means that tracker 501 needs to be exactly at the center. Rather than keeping it unconstrained, we will force it to be at the origin point. Notice that our error is much lower this time, as we already manually aligned this tracker pretty close to the origin point. Now let's turn seed off again. Our first constraint is done. Next up is tracker 502. Turn it into a seed point and tell it to be on the x-axis. But there's a problem. Right now it inhabits the exact same space as tracker 501. X equals 0, y equals 0, and z equals 0. But that is easily fixed by turning seed off again. Now tracker 502 is just constrained to have y equals 0 and z equals 0. Notice that unlike with the *3 method, where SynthEyes gave us this arbitrary value of 20 units of distance, no distance is set up for x. So tracker 502 can be anywhere on the x-axis. For now, let's continue with tracker 503 and turn it into a seed point as well. Then we tell it to be on the xy plane, which effectively means that it is constrained to be somewhere on the ground plane. We can see that once we turn seed off again, that the only constraint for this tracker is z equals 0. Let's head back to the solver room. Once we refine, we see that our constraints don't work so well. Why? Because SynthEyes still has got no idea of scale for this scene. That was why this arbitrary value of 20 units of distance that SynthEyes set up for us with the *3 method was still pretty useful. But here, I don't want to repeat the exact same steps, but rather set up a real-world scale. That means I want to give SynthEyes a proper idea on how big this chessboard is in real life. I don't need to measure the entire board for that. Actually, it is enough that I know for sure that each square on this board is exactly 1.6 inches or 4 centimeters. As I'm European, you will have to deal with me using the metric system. Back in the coordinates room, this is the moment where our trackers 504 and 505 come into play. Select tracker 504 and then press and hold Alt and click tracker 505. You will see two things happening. A gray line will appear between both trackers in the camera viewer, indicating a distance constraint. And in the constraints list, tracker 504 appears with the info that it is locked to tracker 505. All we need to define now is the value of distance between the two. 4 it is. Let's see what happens if we refine now. There's still a jump in our coordinate system, but this time our cube actually gets a little bit smaller instead of unreasonably large. Let's head over to the 3D room and take a close look at the scale of our cube. When I initially created it, I eyeballed it, so it has a scale of 3.714. But let's increase that scale to exactly 4 and eureka! It fits on the square exactly. So this is a huge help, especially if you plan to hand off your match move to a CG application, because models you create or import there will have the correct scale and behave accordingly. Apart from that, once we have a distance constraint in place, our other constraints work properly. To prove that point, we can now kill our solve and resolve from scratch, and our cube will still fall into the correct place. So now you know 2 ways of creating constraints for your scene, but how about changing them? Let's reopen our scene where we set up the coordinate system using the *3 method. If we take a look at the scale of our cube, we see that it is not only larger than the 4 centimeters it is supposed to be, but also that not all sides are exactly the same length. But if we fix that, our cube is just too small. In order for that cube to sit in there with the correct scale, we need to introduce the real-world scaling. Let's take a look in the Coordinates tab. Before we continue, let me give you a little warning. Don't delete entries from the constraints list by pressing the Del key on your keyboard. That will also delete the associated tracker, something you definitely don't want to do. Instead, right-click on that constraint and either choose Clear All Constraints to empty the entire list, or use Clear Except Seed for that particular entry. That way you'll only delete the constraint, not the tracker. If we want to change the distance, we've got 2 options. In a clear-cut case like this, we can just see that 3 squares at 4 centimeters each equal 12 centimeters, so we can change that 20 to 12. But let's say you want to set up a distance constraint somewhere else, because you don't have exact measurements for the area on your x-axis. So let's use tracker 504 and 505 again to set up a distance constraint of 4. Careful. We have now created conflicting constraints because we are telling SynthEyes that the distance for 1 square is 4, but the distance for 3 squares is 20. That doesn't compute very well. So we need to remove that pre-existing distance constraint. We can do that easily by once again changing the locked point status to on x-axis. If we refine our scene now, we once again see a jump. Naturally, because our cube is still larger than 4 centimeters. In the 3D room, we can adjust that scale, and from there I can move this cube around my chessboard like before. Constraints are very powerful, but can also be really confusing. Let me give you one more tip before we finish off this class. I'm going to use the view of the coordinates room, but call up the controls of the 3D room by clicking on the icon for the 3D room instead of the name. By clicking Whole, I can then rotate the entire scene around the origin point. Notice the values up in the constraint points list and also the yellow indicator moving along the x-axis. That is the visual representation of the constraint associated with tracker 502. As we rotate the scene, the error of that constraint is increasing the further we move tracker 502 away from the x-axis. It is still possible to rotate this around 180 degrees and still create a scene that conforms to these constraints. But once constraints are in place, you are also constrained in what you can do to modify your scene. To recap, coordinate systems are vital to navigate your scene efficiently and allow for a sensible visual representation of your 3D environment. Constraints are the key to locking your coordinate system into place once you're happy with it, and also allow you to introduce real-world scaling to your scene. Modifying constraints after they are established can be a bit tricky and might create conflicts. So I would really encourage you to play around with this to understand constraints a bit more, as they can be really powerful, not only for locking your coordinate system, but also for some of the more advanced techniques in SynthEyes. Now take a well-earned rest while I return my son's chess set, And I will see you in the next class, where we will take a closer look at mesh generation and also explore how to log your coordinate system in a scenario where there is no even ground plane. See you there.